get started. Okay, so we're working on PS9 here, today or tomorrow. PS10 will come out tomorrow, and essentially you'll be taking what you've done for PS9. Alright, let's get started. And you will be replacing your static variables with the database. So you keep the state of your representation in the database instead of in the poor man's database. And furthermore, you'll have the grading tests for PS9, which will be the same as the grading test for PS10. So that's good too. Are there any questions or problems? Yes?
When a player leaves the game in progress, should the game continue or should it be marked completed for the other player?
Well, how does a player leave a game? Say what? Well, how would the server find that out? See, there's nothing in the API to tell the server that a player has left the game. So basically a player can't leave the game. They can just stop participating, but the game goes on and stays active until it's not active anymore. Yes?
So the grading tests will not be available until after PS10 is due?
No. The PS9 grading tests will be due after PS9 is due.
Okay, they'll be available?
Yeah.
Okay.
And then you can use them for PS10 as well. Yes?
So when you're using the data attributes and the default values,
Yep.
when we want to return the time left and it's 0, but it's emitting the default value of 0, how do you make it so it...
Okay. If you dig deep enough, you can find a discussion of that on Piazza. It's basically like this. If you put a question mark after say you declare a variable like that, that's called a nullable type. So you can take a value type, put a question mark after it. Now you have what's called a nullable type. So it's just like an int, except you can also store a null in that variable. And so in that case, you declare your time to be of that type. So the default value would be null. Yeah?
You know, is that the same as doing that annotation that says emit default value equals false for the, is that the same?
Well, his problem was, so he's declaring his time left as this. So he has a time left property. Okay? The default value in int is 0. And so if you have time left annotated to not emit the default value, then when time left is 0, the property is not included in that output. But if you declare it this way and store a null, if you don't want it to display, you store a null in it. If you don't want it to be serialized, you store a null in it. If you store a 0 in it, the 0 will be displayed. Other questions? Yes?
Does that work for all primitives?
Say what?
Does that work for all primitives?
Yeah, it works for all value types. Other questions? Okay. If you think of any, let me know. Okay, so since next week you'll be sticking a database into your project, we need to talk about, last time we talked about databases and queries and commands and how to manipulate databases from the query analyzer. In lab yesterday, you went through how to create a database schema in Visual Studio so that if you did it, you now have a database set up that you can use for next week. What remains is to put it all together so you see how to access the database from C# code. So how do you programmatically access a database? And I have some code examples here, but before I do the code examples, I want to show you some slides. But before I do that, this is a question that I blew on Piazza. The issue was opening dictionary.txt. So you got to open dictionary.txt. So clearly you can say something like create a new stream reader, and then give an absolute path to dictionary.txt. That's no good, because then we won't be able to use it when we put it on our machine. This is a way to do it. The way I suggested apparently doesn't work, or it doesn't work all the time. You just take dictionary.txt and append to the beginning of this thing here. And that's sort of a portable way to open the dictionary.txt file. Yeah?
That way you have it work for me. I just had to move the dictionary.txt file into the binary debug and release bins for both of the projects that we're using, which was the testing, and it worked for me. So,
Yes, and I guess while it wasn't working, it was supposed to move automatically when you set the property to copy always. But I guess it wasn't being copied. So anyway, whatever, as long as you're not using an absolute path, you're okay. But don't use an absolute path. Maybe I'll amend this again, figure out what's really going on. Okay, now to this. All right, so we're going to talk about the basics of how to use a database from the C# program. And after we do this, we'll actually look at examples from my to-do list server. After we see the high points here. Okay, so the first thing is, before you can use a database, you have to open a connection to it. So let's say you have a method that's supposed to do you often end up having to do more than one thing to the database. Maybe you have to insert a couple things, or delete a couple things, or run a couple queries, whatever. So what you can do is open a connection, like I'm showing you there. Then do whatever it is you have to do. It could be a long sequence of stuff. And then the connection automatically will be closed when you exit this using block. In a high-performance application, a lot of times they don't want to keep opening and closing down connections. So they'll open a connection and just, in fact, they'll open up several connections and keep reusing them on different threads, so you don't have to keep reopening connections. But you're not doing a high-performance application, so it works just fine. When you need a connection, open it, use it, then close it. Now, when you open the connection, what goes right there, those dots, is called a connection string. So when you use a database, let's say you're using MySQL, it'll have directions for how to create the connection string to access it. So what information do you suppose you would have to give in a connection string in order to connect to your database running on a MySQL server that's running somewhere in the world? Yeah?
Database name host.
Okay, so you got to give the name of the host. You have to give the path, right? The domain name. So there'd be some URL, http:// blah blah blah. It would be, basically the internet address of the web server, of the database server. Okay, what else would you get? He actually said it. The name of the database. So the server is hosting a bunch of databases, so you give the name of your database. What else? You think anyone can get access to a database by just specifying the name of it? Yeah.
User and password.
Right. Now, on a server like that, you'd have a username and a password, so that would go in connection string as well. And they would be glommed together into a string in some fashion that the documentation says. So any server you're using, you can typically get it to generate the connection string for you and then just use it in your program. In your case, you're not using a remote server. You're using a simple database built into Visual Studio. So there are no accounts or no usernames or passwords. And I'll show you what I have to do for a connection string. It's really straightforward. I'll show you when we get into the code. It's a good idea to put your connection strings into a configuration. What you'll see is my code. I have the connection string stored in a configuration file, and I just access the configuration file from the code and then use that. That makes it easy to point your application at different database servers, which is something, for example, you'll do when you put your application up on Azure. We'll be actually using a database on Azure, so you need to change the connection string. Okay, so that's the first step. Open the connection. Okay. Now, when you access a database, you want to do it inside of a transaction. So this would be nested inside of what I just showed you, inside the using that opened the connection. So we begin a transaction on that connection, and you do stuff. And when you're through with a transaction, you've either got to commit or roll back. And if you forget, you've implicitly rolled it back. So commit means keep all the stuff I did, keep the changes. Rollback means cancel. So if you forget to commit, your inserts, your updates, your deletes won't have any effect. Now that doesn't explain why we use a transaction. That's what I'm going to do for a bit here. Essentially, the transaction, you're saying, start the transaction here, do some stuff, and then end the transaction. So it's a unit of work. And the database system guarantees atomicity and serializability. So atomicity means the transaction will either run completely or not at all. So let's say that your program is in the middle of a transaction and your program crashes. It never finished the transaction. The transaction will have no effect on the database. It's as if it never ran. So it's not like it'll leave the database in some half-written state, in some half-modified state. If it doesn't run to completion and commit, it's as if it never ran. Or suppose the database crashes while you're in the middle of a transaction on it. Again, when the database comes up, there'll be no trace that that transaction ever ran. Yeah?
So if you assuredly want certain things to happen, you should have them on their own transaction and have a separate transaction for the thing that may or may not succeed.
Well, what do you mean by not succeeding?
Rolling back.
Yeah, well, typically, you typically roll back a transaction. Say if there's an unhandled exception, your code crashes in the middle,
Okay.
and so you roll it back. But yeah, but you don't want to take the attitude that you make every little thing you want to do its own transaction, because a lot of times you have multiple things you want to do, but you don't want half of them to be done. You either want all of them to be done or none of them to be done. That's why you use a transaction. The other thing it guarantees, besides atomicity, all or nothing, is serializability. Now this is a different sense of the word than serializable when we're talking about converting something to a string. What that means is the database system is multi-threaded. You've got, think of a production database with lots of databases. Each database has lots of users and they're all banging on it at the same time. You could have a couple transactions running at the same time, modifying the same table. Or one might be reading the table and the other is modifying the table. Or they might both be reading the table. So they can potentially interfere with each other. So the atomicity guarantee is, when it's all done, it will look like the transactions ran in some sequential order. It will never look like that you won't be able to detect that some other transaction interfered with yours. If you've got, imagine you have 10 transactions running at the same time. They may literally be running at the same time, all modifying the tables at the same time, but when it's done, it'll look like they ran one after the other. You don't have to do anything. You don't have to set locks. You don't have to worry about threading. You just start the transaction and the database system takes care of the rest. So this is the guarantee that, how is it able to make that guarantee? How can it guarantee that it's going to look like the transactions were running, in a single thread, one after the other, even though they're all running at the same time? Yes?
So is a transaction required for any and all interactions with the database, like even a simple read, where there would be no changes?
Well, suppose you're doing a simple read. Well, first of all, if you're interacting with the database with a single query or a single statement, that's automatically a transaction unto itself. So strictly speaking, you only need to use a transaction if you've got more than one statement. But even you care about transactions even if you're reading, because you don't want a situation where you were reading and then the table got modified and then you finished reading, because now you've got an inconsistent view of the database. It's not serialized. So yeah, transactions are always important. But I was asking a question. What was my question?
So does it just keep track of, like, this was when this call was placed, this is when this change was made? Like,
Well,
and give them a priority status that's like accordingly?
well, I mean, that's a reasonable guess. Think about suppose you were implementing a database system in C#, and you're interpreting queries, and it's multi-threaded. What would you have to do to make sure that chaos did not ensue when multiple queries being executed at the same time? Yeah?
You'd be using locks?
You'd be using locks. You'd be doing lots of synchronization. So the database is really intricately coded. That's why I'm saying you can't compete with a real database system. And it's smart enough it puts locks where appropriate, and it detects when there's a problem. Now, there's a price that gets paid. Generally, what a database system will do is use a minimum number of locks and just hope that two queries won't interfere with each other. And it sort of lets them proceed. If it detects at some point that something fishy is about to happen or has happened, where it's no longer serializable behavior, it will abort one of the transactions. So occasionally you'll try to run a transaction and it will fail. And what that means in C# is you get an exception that the transaction failed. That doesn't mean that the queries are wrong. It just means that two queries are running at the same time and they interfere with each other such that one of them had to be shot down so the other could complete. So it's possible that you get unlucky and your transaction is aborted. Yeah?
Do you ever notice the message that it sends back?
Yeah, off the top of my head, I don't remember even the name of the exception.
But does it seem to imply like you got unlucky and said you wrote it wrong?
It should, but I just don't remember. So what should you do if your transaction is aborted? You get an exception that says your transaction is aborted. Yeah?
Just trying to do it again.
You can try it again. Right? Because when you try it again, the transaction that was interfering with it is done, and you'll probably succeed. Yeah?
Is there learning that happens that like would add another lock?
No, it wouldn't be learning. It would just be... the reason you can't avoid this altogether is, first of all, another thing that can happen with locks is deadlock. So sometimes it might determine that two transactions are deadlocked. So it could avoid having to abort transactions if it was much more aggressive about setting locks.
Okay.
Right, and only let one transaction run at a time. But it's trying to increase throughput. So it's doing this balancing act between letting things run at the same time and optimistically hoping nothing goes wrong. And occasionally something will go wrong and it has to abort a transaction. Okay? Now, my example code, I was too lazy to actually handle the exception where the transaction failed. Now, honestly, it may very well not ever happen to you. I mean, I don't know how common it is. It's certainly possible. The other thing you can do is just report to the user, oh, there was a problem, you try again. Right? The user triggered it. Like, oh, I couldn't create the user, please try again. And I'm sure you've all seen error messages like that. Unexpected problem, please try again. So who knows? Maybe that's triggered by a transaction aborting somewhere. But this is the nice thing. You're getting the benefit of multi-threading on the database side without having to do any of the work other than catching this occasional exception. So this slide just summarizes what I said. Now, I said it makes these guarantees of atomicity and serializability. They're actually what are called isolation levels. So the default, as far as I can tell, is sort of the strictest, the serializability that guarantees serializability. But you can choose lower isolation levels that produce weaker guarantees of atomicity and serializability. So it may be that you can put up with certain kind of conflicts between transactions, in which case you get better performance. But you have to sort of really deeply understand the database before you should be changing the isolation level. So I would just go with the default. Okay, now, so you have created a connection. Inside that using block for that, you've created a transaction. Inside the using block of that, you start creating commands. So this is an example of what would be nested in there that's creating a command. And it just looks like this. New SQL command, and then you give a string with dot string. What is that? What does that string stand for? Those are just statements like we were typing into the query analyzer on Tuesday. Select star from users. Delete item where item ID equals 7. So that's where the queries of the type, the queries in the statements, the commands that we were using on Tuesday would go. So typically what you would do is you would decide, I need to run this query at this point to look something up or change something. What I strongly recommend you do is you take the query that you want to do, experiment with it like we were doing on Tuesday, debug it, get it to work right, then paste it in. Don't be trying to, debug your syntax via a compile execute sequence on your server. Now, once you've created the command, you can run it, and how you run it depends on what kind of command it is. So if it's a straight query, a select statement, you run it this way. If it's a update, insert, delete, you run it that way. And occasionally you use this way. And the main use case for this is you've done an insert that has auto-generated a key. And you want to know what that key is because you need to use it. And so this runs the insert and gives you back the auto-generated key.
Like game ID?
Like game ID, yeah. So I guarantee I'll get, Piazza will have several people ask that same question next week. How do I get back the game ID that's auto-generated or whatever? And that's the answer. And we'll look at an example in code with that. Okay, so let's look at executing a non-query. So by a non-query, I mean a non-select statement, an update, an insert, a delete. You just say, okay, you give this statement to execute. You specify the connection, the transaction you're running inside of. And what it does is it runs it, and it returns the number of rows that were modified. Now, why would you be interested in the number of rows that were modified? Yeah?
So you can tell if your update was successful?
Right, you can tell if it was successful. I mean, maybe what you're doing is someone says, your user sends you an item ID and says, change this one and mark it as completed. And so you're updating the table. And maybe you try to update the table and you find out that no rows were changed. What that means is the user gave you a bogus item ID. And so you could, if you get a 0 back, you could report to the user, you gave me a bogus item ID. If you get a 1 back, you say, okay, it's marked complete. You can tell it worked. So that's why you look at that return value, just to see what happened. For an insert, you would expect it to be 1, because you're inserting 1 row. For an update or a delete, multiple rows could be changed. Okay, so that's executing a non-query. Yeah?
So if you change something in one table and it has some other data relationship in another table and it also changes that, would it come back as 2?
Well, these things only work on one row, on one table, right, unless you have a foreign key constraint.
Right.
So, but it would still just report. So you're changing, let's say you're changing an item ID, and that means it has to be changed everywhere the item ID appears in this other table. You got that set up to happen.
Yeah.
It would only report the change on the first table. Yeah. Okay, that's that. Execute scalar is the one I mentioned that. Let's say you're doing an insert and you want to get the auto-incremented key back. You just do it like this. You execute it, execute scalar, and then what you get back is the key. You can cast it as appropriate. And then for running a select statement, you use execute reader, and what you get back is an SQL data reader object. And you can use that data reader object to write loops that consume the rows. And we'll see an example of that shortly. So you'd be doing that for select statements. You'd be doing that for everything else, and occasionally you do that when you need to get an auto-generated key out. Okay, now the problem with databases is if you know a little bit, you can write a program that uses databases, but you'll probably write one that's insecure. And I'm going to show you one thing that can go wrong. This is probably the most prominent thing that can go wrong. suppose that we're using my to-do list thing, and the user is supposed to give you a task ID to delete. So the user says, here's a task ID, please delete it for me. So you create the query, delete from tasks, where task ID equals, and then you append to it the task ID the user gave you. So if they said 27, it's going to say where task ID equals 27. Fine. You execute it, and the row with 27 on it, ID 27 on it, gets deleted. But what if the user typed that into the web form instead of 27? Yeah?
They would be using SQL injection to exploit the
Okay.
database, and it would affect multiple tables, but not supposed to.
Right.
Or rows.
This is called SQL injection. What would happen if you took this right here, just say you got this string from the web form, you didn't check it to see what it was, to make sure it was a number, and you just appended it to that partial deletion up there? What would happen? Yeah.
The whole table would be cleared.
The entire table would be cleared. Every row would be deleted, because our command would say, delete every row where task ID equals 0 or 5 equals 5. That's always true. So, SQL injection is when you take input from the user and paste it into a query, and the user is nefarious and has figured out exactly what to type in there that will cause your query to do something you didn't expect. Maybe destroy your database, maybe break security and give you stuff back they're not supposed to have. It's a very common attack to try. Yeah.
How do you check that though? Like,
All right, how do you check that? Okay, first of all, do you understand the issue? What's the root problem? What is he? Yeah, so where did I screw up?
You're
Yeah.
allowing too much freedom.
What's that?
You're allowing too much freedom, like, for them to.
Well, basically I screwed up by trusting the user and not checking what was happening here. But mainly, I screwed up by directly pasting something from the user into my query. That's a no-no. Don't do that. Yeah.
Your code is set up to accept typed code, in this case SQL format, from the user instead of commands. They could, if you're letting the user put in actual code in your program instead of numbers,
Yeah.
then
Right.
you're
You wouldn't take something a user entered in a web form and compile it and run it. Right? So you shouldn't do this, even though it's tempting because it's simple. Right? So it's mandatory when you teach databases to use this XKCD comic. It's called Exploits of a Mom. So we see mom here talking to her son's school, and they're saying, we're having some computer trouble. And she says, oh dear, did he break something? And away. And they say, did you really name your son Robert, close quote, parenthesis, semicolon, drop table, student, semicolon, dash dash. So that's meant to suggest an SQL injection attack that would get pasted into a query and delete the table. And, oh yes, little Bobby tables we call them. So, I hope you've learned to sanitize your database syntax. Okay? So just Google Bobby tables whenever you want to use this example, and there it is. Okay. So how do you avoid it? It seems like we're asking a lot if we have to look at anything a user types and determine whether or not it can cause some trouble. So this is how you do it. You just work slightly harder. Create your query like that and put a placeholder in it. So @task ID is a placeholder for where some data needs to be put. And then, before you run it, you do this. And maybe a way to abbreviate this, I'm not sure. But you're just saying substitute the task ID provided by the user for that @task ID up there. It sounds like we're just pasting it back in and going to have the same problem, but it does it in such a way that it guarantees you won't have the trouble. It automatically escapes things that need to be escaped. It sanitizes the input. It makes it so if they type that stuff again, it'll get pasted in there, but it'll be escaped, so that it'll just be task ID equals some string, and that won't succeed. Yeah.
This methodology would prevent all forms of SQL injection toward the specific program? Out of curiosity.
I mean, it depends how broadly you define SQL injection. But yeah, for any kind of query you're going to write, the way to avoid SQL injection attacks is to use this technique. If anywhere you want to paste input, you just stick an @ thing, and then you do this. You do this for each thing you need to paste in, and it gets sanitized automatically for you. Basically, in this case, what would happen is this would be surrounded with quotes. And then you end up with a query, task ID equals quote, blah, 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 end quote. If that was all it did, though, people would start putting quotes into here to close the quotes prematurely and mess it with that way. So if you put a quote mark in here, it would backslash it. Right? So leave the sanitizing to the experts. You just got to avail yourself of it. Yeah?
Suppose you knew what sort of input and you just only accepted integers and then did integer to string, for example. That sounds pretty foolproof.
Yeah, you could say, okay, I want an integer, you parse it, make sure it's an integer, and you paste it in, and you'd probably be okay. But I would still be wondering, you got to overlook something. Is it possible it could be too big? Could it cause some problem? Don't worry about that. Why put yourself through that? Just do it this way and let the database vendor worry about it. They're a lot better at it than you are. So. And, this has the potential of doing real damage. I mean, when you finish this project, you'll know enough that you could, I could imagine working for a small company and they need a website set up and you say, oh, I know how to do databases. And if you didn't know about this, you could easily create a tremendously insecure product. So that's what's scary about this thing is it's really easy and tempting to produce something that's easily attacked. So do us all a favor and at least get into the habit of not doing that. Okay, now, if we back up a few steps, we were talking about, in fact, I will back up, that we have this execute reader call that executes a select statement. And I promise to show you how that works. So, you do execute reader, you get a reader object. So you can write a loop. There's this read method. Reader.read moves to the next row of the result. Remember, you're watching it, essentially getting back a table. It moves to the next row and returns true if it succeeded, false if there's no more rows. So you can say while reader.read if you want to read all the rows. You can say if reader.read if you want to read just the first row. And then once you're in here, you can do something like this, reader, and then you can, I'm assuming description is the name of a column. You put the name of a column in here, and it will give you back an object, which is the contents of that column. And you have to know what type of thing you're expecting and cast it. There are other versions, like you can say reader.read string and pass it an index, and it'll return the contents of the column of column 3, let's say, in the current row. So there are various methods. But that's the idea. You read one row at a time. This lets you pull the columns out. You just need to know the names of the columns. And then you get the data out, you do whatever it is you're doing with it. Okay? So those are the high points. Let's see if there are any other questions before we consider actually seeing how this looks like in a program. I mean, it's not particularly difficult. It's just the code gets a little bit bulky because we're opening a transaction, opening a connection, starting a transaction, opening an SQL command, and then creating the reader. So that's 4 nested using statements before we get down to writing this loop that's actually doing the business. And so the code gets long, but most of it's boilerplate. I'm surprised they don't have a shorter way. You just maybe they do. Maybe there's there's some way to condense all that. Okay, well, let's take a few minutes off, and then we'll look at some code. All right, let's get started again. All right, so now we're in code. So this is my, I have my to-do list server, which you may remember we worked with a to-do list client in class once upon a time. And so the main class is called to-do. And what I have here is called a static constructor. So I've gotten that question from a number of you currently. You have some static variables, obviously, in your current implementation. And there's some things you want to do maybe that you need to initialize the static variables, which you just write the initial value next to them. But there's things that other people want to maybe hook an event once when the server started. And the way to do something once when something starts is to create what's called a static constructor. So this is just, you put static, it looks like a constructor except you say static in the front. And it runs when the class is loaded, and it can only mess with static variables. So that's just sort of a general purpose piece of information. So static constructors are useful. And what this static constructor is doing, besides hosting this huge comment, is initializing the connection string. So this variable holds the connection string for my database. And I'm going into the configuration file and pulling it out of there. Right? Because I mentioned it's good to get the connection string out of your code so you can change it easily. So right here, this is inside the web.config file. I added connection string section, and then I have BoggleDB, and here's the actual connection string. So the code I showed you pulls that out. You can see what my connection string looks like. Well, there's integrated security equals true, but that's the bulk of it is essentially saying start in my data directory and look for to-do-db.mdf. But you need that whole bunch of stuff to make it work. So just stick it in one place and load it when you need it. So no need to try to copy it down now. Just know where it is. So you can. What this comment says, you could write your connection string as C:\user exactly blah blah blah, but now it's non-portable. So that's why I suggested shortening it, just putting this thing here, and find the data directory inside your project, and find the right file there. And that makes it portable. Okay, so we're going to have to do DB will be our connection stream. All right, here's the register method. So this is we're registering a user, and we're getting, I guess, the name and the email address or something when someone registers. And so typically you want to check the input and make sure it's not bad input. So we make sure that the name isn't null and that the length is not 0. There's something else we probably also ought to check. I was kind of sloppy here. Usually when you have a column in a database table that's a string, usually to give its maximum length we need to declare it. So you do something like varchar 50, which says it's a string of up to 50. If you try to add more than a 50-character string to that column, your attempt will fail. So here, I should have been checking to make sure that the string wasn't too long to fit in my database and complaining if it was. You'll remember there's a limit in the Boggle server, right? It's like, is it 50?
Yeah.
So, same idea. So we make sure that our inputs make some sense. Then, you can see up there that using statement, I'm opening the connection like I showed you, and I'm just passing in the static variable that holds the connection string. I open the connection, I begin a transaction, like I showed you. And these comments you can look at later. I created the command I want to run, which is just insert into users, user ID, name, email, the following values. And again, rather than paste in the user ID, the nickname, and the email, I are going to put them in the way that I showed you. All right, so I've created my command. Then let's see, I generate the user ID up there. And then here's where I replace the placeholders with the generated user ID and the user provided name and email. So they get embedded into the query. So now I've got a well-formed query. I execute it with the execute non-query. If I get back anything other than 1, I say query failed unexpectedly. It's hard to imagine why I would get anything back other than 1. Then I set the status. What if I didn't do that?
Everything,
Right, it didn't happen. There'd be no record the insert happened. So you got to be sure to do that. I used to write the code so that it called any exception and did a rollback when it called it. Then I decided if you don't commit it, it's rolled back anyway. So why not? Do you have a question?
Transaction, actually.
Okay. So don't forget to commit your transaction. And then return the user ID. All right, so that's a simple one-statement query, or one-statement action. Took 2 pages of code. Or most of them were comments, but still, it is kind of a lot of code to write to do a single insertion. But it all has a purpose. And notice, I'm not catching any exceptions, and I probably should be. It'd be nice to, if the transaction fails, which probably be thrown by that commit right there. We could catch it and retry if we wanted to, or just tell the user to retry. Okay, now this summarizes it. This comment here summarizes that. Let's just talk for a minute about unhandled exceptions. What should you do? What should a server do when it gets an unhandled exception? I'm sort of just blowing this off on your assignment, not worrying too much about it. But really, if you're running a real bulletproof server, what should happen when there's an unhandled exception? Yeah?
Return an internal server error message.
Okay, so you want to report that something went wrong. Should you say internal server error with no details, or should you say internal server error and give the stack trace that comes with the exception? Yeah?
Does getting the stack trace make the possibility that a user has way too much information about your system now?
Yes. It's a bad idea to give the stack trace back to a user, because that's one of the ways that hackers use to hack your program. They need to learn about it. They need to find out why something failed. For example, they may be trying to do SQL injection, and they don't know what queries are in there. So they're just trying stuff. If they get to see the exceptions that are generated, those exceptions may contain information that reveals to them what query was being used. The type of failure can give them information. So you don't want to do that. It's useful when you're doing debugging to see that exception. You do not want to give that back to the user. So what should you do with the unhandled exception? Just throw it on the floor? Yeah?
We could store it somewhere so that us as the server host can look at it
Right.
and analyze it.
Right, you want to store it somewhere. Basically, there are a variety of logging systems you can get. You know, logging packages that you can install that make it easy just to take something like an exception and log it. So there'll be some file somewhere that the server, whenever there's an exception, you can configure things so that it automatically writes information to the log file. And then you can go back and look at the log file, and if you see you're constantly getting the same exception, you know, then you've got help debugging it. But yeah, you don't want to reveal that to the user. All right, here's add item. So we're getting an item object in, and that contains, I don't remember what it contains, probably the, at least the description of the item, whether it's completed or not. Again, we start the connection, we start the transaction, we issue the command, and the command is select user ID from users, where user ID equals @ user ID. What are we doing here? We're trying to add an item to the database. What the heck? Why are we looking up a user ID?
A foreign key in your system?
It's not because it's a foreign key. But the user ID is part of the, no, I don't see the top here. It's part of the object that came in. So we're saying, I'm this user, add this item to my list. Yeah?
Yeah, I was just going to say that way, if you try to throw in an item that doesn't have like a valid user associated with it, you catch it and throw some sort of message back.
So here I'm just checking to make sure that what I got was a legal user ID. I'm checking credentials. So what I do is I run a select, I execute the query, and I don't care what comes back as long as there's one row. If the user ID was valid, I should get a row back. If the user ID was invalid, I'll get no row back. So if there are no rows, then I set status to forbidden like I'm supposed to, and I'm done. Yeah?
What does committing a read? Or am I misunderstanding that? It seems like you're committing a read.
Yeah, the only thing this would do, the only reason that, I'm just doing it for completion. It could possibly fail though, it depends on how, you know, if we did a partial read and then there was a write and then there was a partial read, it conceptually could fail, but I don't believe it really would ever fail a read. I think it's write transactions that get failed. That probably doesn't matter. This doesn't need to be in a transaction at all, I imagine. Okay, so we're just checking to make sure that that user ID is valid. Then we have to do the insertion. So you can see, we issue the query, insert into the items table. We're going to insert these three, these are the columns we care about. User ID, description, completed. What's this stuff at the end here? All right, here's where the actual values go. What's that? What's right here? What's starting right there? Output inserted .item ID. Yep.
You're telling it where you want it to update that information into?
No, it doesn't have to do with the update. Well, we'll come back to that. So you create that query, you plug in all the different values you want. Notice, I'm so paranoid about this, I even paste in constants that way, right? Rather than putting false directly into the query, I add it this way, just, I don't know why, but it seems safer to me, at least uniform. Then I use the execute scalar command to do the insertion because I want to get back the item ID that was created. Now, let's go back to this. What is this for? Yeah?
Is that making an object for you to work on?
No. No, not that. Yeah.
So just return the item ID when that transaction.
Right. That's what you have to put that into the query. So in MySQL, I was thinking about MySQL when I was talking about this before. It automatically, you do something like this, it automatically will make the auto-generated key available. In TSQL, which Microsoft is using, you have to actually say, the result of this should be the item ID that was generated, the new item ID. So you put that there, and then you do execute with Scalar to grab that thing. So that's in the query so that the item ID will be returned by execute Scalar. And we convert it to a string, store it, and go. Okay? So that's an example of an insertion. But notice first we did a select to validate the user ID. Can you think of a way we could have gotten away without checking that the user ID is valid? Yes?
You do your queries for multiple tables at the same time.
You can certainly do selects on multiple tables at the same time.
Can you combine a select and insert?
No, you can't combine selects and insert. So let me make it clear. I don't want to end up with a bogus user ID in my table. I'd like to just wipe out that entire select. There's a way to do it. What would happen? Yeah?
Do you do insert, what do you do when you insert, try to insert where user ID equals the right one?
No, that wouldn't work. Well, suppose we just go ahead and do the insertion. Are we going to end up with a bogus user ID sitting in the table, in the items table? How do you prevent bogus user IDs from being in a table? Yeah?
And were the tables associated with one another, the constraints between those tables?
Right, the foreign key constraint. So if you set up a foreign key constraint that says you cannot have a user ID in the items table unless that user ID appears in the user table. If you set it up so that, and say if that constraint is violated, throw an exception, or fail the insertion, then all you have to do is try to do the insertion, and if it succeeded, good. If it failed, you would know it failed because the constraint was violated, which means the user ID is bogus. So that would shorten the code quite a bit. So you can exploit your constraints that way, your foreign key constraints. Okay, here's mark completed. So this is where we're getting in an item ID, and we're supposed to mark it as completed. So once again, open the connection, start the transaction, issue the command. The command is update the items table by setting completed to true on every row where the item ID appears. Okay? And so then I paste in true and the actual item number. Execute the query, and if I get 0 back, something went wrong, probably the item ID doesn't exist. So I do that because item ID didn't exist, otherwise I set the status to OK. Okay? So, I mean, this is, nothing deep. But this is going to be something really valuable to look back on next week when you're trying to remember how to do things, because I'll sort of do one of each in this example here. Yeah?
So in these examples, is it just really hard to write code for a database that you don't actually know all the information about? Like, for example, you're saying equals 0, so you're saying you know that's an int.
Well, yeah, well, that's just a C# feature. This method returns an int.
Oh, okay.
But yeah, to write for the query for the database, you have to know the names of the tables, the names of the columns, what the foreign key constraints are. Yeah, you got to know all that. If you didn't, you'd have to guess, and yeah, you're a hacker then. You know, a black hat hacker. If you're trying to write code against a database you don't know. Okay, this deletes an item from the database, and you're getting used to it now. Open the connection, start the transaction, delete from items where item ID equals @some item ID. So that's the example that I had for SQL injection. We guard against it by this line right there. Then we execute it, and we either say the item ID if it didn't exist, we set status if it didn't, otherwise to OK. And finally, here is an example of a select. And select takes, post-processing after you execute the query. So we do that stuff up there. We create the command. And the command says select the user ID. What is this supposed to be? Get all items. So we select user ID from users where user ID is @ user ID. So here I'm validating the user ID, like I did before in the other query. I'm making sure the user ID exists. And I'm bailing out if it doesn't exist. Then I say, I select the description, the completed, and the item ID. So I'm doing a join. So that query is a join. It's getting data from two tables, from items and users. And I may add to the query depending on what options the user has specified. Right? If they want to know only the completed items, I add and completed equals 1. There being no true, there's no true in TSQL, so if you want to say true, you use 1. If there's no user ID, if there is user ID, rather, then I'm just looking for items that match the user ID. So I'm building the query up depending on what options the user specified. So I build the query, I execute it, and then I start reading it. So this just shows you, let me pull it down. We write a loop while reader.read. So each time we go through the loop, we're looking at another row from the result. An item, an item, an item, information. So I pull out the description and cast it to a string. I pull out the completed information and cast it to a bool. I pull out the item ID, convert it to a string. And I'm using that information to instantiate a new to-do item. And then I'm adding it to a list of to-do items. And then in the end, I return that list. So that's what this method is supposed to do. So it just loops, and as it loops, it builds up a list of to-do items, 1 per row, and returns it. So this method is supposed to return a list of to-do items, which is what it's doing. Pulling the items out of the database, return. Yeah?
What's your opinion of yield return when you're dealing with SQL across the network?
Never thought about that. The thing, if you wrote this with a yield return, what he's getting at is, so I'm building the entire list and returning it. I could have used yield return. So I'm down in here, and instead of adding this to a list, I could just say yield new to-do item. And then that would yield it to whoever's consuming this. Presumably someone's consuming it to build a web page to give the result. Or the client, something's consuming it. What would be, why is there an issue? Why not use yield return? Yeah?
If you don't go through the entire list, it may never commit. The transaction may never commit.
Well, right, so the thing is, okay, let's say that you never finish this loop. So you yield something and then the program terminates. So the question is, what happens to this code here? Will this stuff down here ever be executed? What I was thinking about is that you suspend, you do a yield, this code suspends, some other code's consuming it somewhere. You're holding that database connection open. You're holding a connection open, a transaction open, a command open, a result set open. Those are all resources that you're consuming without releasing them. So yeah, I'd have to think harder about it, but you can see what the potential perils are. What's your opinion?
My first thought was if I was trying to return all the results that Google has, I would not want to build a whole list first.
That is true. But you also wouldn't want to hold a database connection open
Right.
while you enumerated all the results Google has. So probably the architecture you use there is do some sort of query that gets, you can put a limit on how many rows you get back. You say, I just want 100 rows. So you can get 100 rows and deal with them, and then if you need more, ask for the next 100 rows. Something like that. Any other questions? All right, so next week we'll be doing something else while you'll be doing databases. It's been for a while now. We're talking about the very thing you're not trying to think about while we're talking about it. So anyway, if you didn't get anything else out of this, just remember the slides give you the overview. This particular project here, which is to-do list server in my examples repository, chock full of comments, and it ought to show you how to do. It ought to be an example for any kind of thing you need to do in your server. You've probably found that the server you're doing this week, what percentage of the work is getting the configuration just right, and what percentage is writing the code once you can call the methods? What's been more work, the code or the configuration? Maybe you haven't even gotten to the code yet. The questions I've gotten have almost been all about configuration. Right? You don't have to redo any configuration next week. Right? You just replace the code. All right, we'll stop here.